Hi, in this video we're going to talk about how to analyze a function beyond just doing domain and range. To start, we want to focus on the slopes of a graph. So if you were to trace a graph from the left side to the right side, and that's really important to always go from left to right, that graph is either going up or down. So we're not focusing on these arrows, right? Even though our arrow is pointing up, if it's the leftmost part of the graph and I'm tracing, this is actually going down. That would have a negative slope. I'm going to make something called a slope number line. So we're going to mark the places where the slope has a change in it. So we're going to mark down that right here we have a negative slope where I've highlighted that in yellow, and it changes at -3. From there, we're going to have an increase, right? From here we were decreasing and now we're increasing. That means that that's a positive slope, and that goes until an x value of 1. We have one more piece of the graph. If we keep tracing, this right here is going down, so I kept that yellow to show that we actually have two parts of this graph that have negative slope. So we really have three pieces to this graph, right? That first piece has a negative slope, the middle piece is positive slope, and the third piece is back to negative slope. That's going to be very useful when we analyze this graph further. Something that we like to write down are the increasing domains of the graph. So in this case, that was where our graph was going up or had a positive slope, right? This green portion right here. And we write it down as its domain. So we're going to use the x values of that green portion. In other words, we're going to look at the x values on our slope number line here, and we're going to write down from -3 to 1 being the increasing interval. We also care about the decreasing intervals. So that's where the x values were increasing, meaning we were going from left to right, but the y values were decreasing, right? The tracing was moving downwards. That was a negative slope. So we need to write down the domain of the yellow parts of the graph. So we have two chunks to that. We have the -infinity to -3 and the 1 to infinity. You might wonder why I have parentheses around these values, where we traditionally would have brackets, right? Since these points right here are actual points on our graph, they're not holes. We like to use parentheses because at that point itself, the graph isn't going up or going down. So we don't like to include it in those intervals. Something else that we like to look at would be the extremities of the graph. So we can look at the absolute maximum or the highest or largest y value that's in the range. In this graph, because we have this arrow pointing up all the way, we wouldn't have one for this. The absolute minimum would be the lowest point or the smallest y value in the range. We wouldn't have one of those either since the arrow is pointing down. But we also have something that's a little weirder. Those are called relative maximums and relative minimums. So relative maximums happen where the slope changed from positive to negative. And you can see it over here as like a bump, right? It's like the top of a bump. That place right there is called a relative maximum. In its neighborhood, it looks like it could be the highest point on the graph. But if we looked at the whole graph, we know that there are going to be points over here that go higher. It's still good, right? It's still special. We want to make a note of that. The relative minimum is where the slope is going to change from negative to positive, right? So right here, that happens at -3. Here's the point, right? That red point right there. And again, it's not the lowest point on the graph, but in its little neighborhood, it looks like it's the lowest point just in that area. The last thing that we're going to talk about is end behavior. End behavior is just a fancy way of talking about the arrows on a graph, where they are headed. So this graph has two arrows, right? We will describe what happens as x approaches -infinity. All that's saying is, what is this left arrow doing, right? Because we know it's moving left, that's towards -infinity. And what is the right arrow doing? That's where x approaches positive infinity, right? Those two arrows. Let's say this is the graph called f of x. There is a limit notation that can be used where we would say as x is approaching negative infinity, the limit of f of x is going to infinity. As we look at the blue arrow here, this is as x is going to positive infinity, f of x is approaching negative infinity. We really can just write that as sentences. So this is what we want to focus on here. As x approaches infinity, that's the blue arrow, right, going to the right arrow is pointing down, so it is approaching negative infinity. The yellow or orange arrow over here, that's the left arrow. As x approaches negative infinity, f of x looks like it's increasing here, right? So that's approaching positive infinity. Okay, so let's do a few more examples. Here's a graph, doesn't have any arrows on the ends, and we just want to identify the increasing and decreasing. So if we trace this from left to right, that was going up, that was going down. Do it one more time. This is going up, this is going down. My job is to write down the domain of where it is increasing, right? So here is the domain. From this value, it's x is 0, to this value, it's x is 3. So from 0 to 3, the graph is increasing. And from this value, that's 3, down here to this value, that's 8. So 3 to 8 is decreasing, right? And those are like writing down the domains of the little chunks of the graph. This is what it will look like on Delta Math. There's also a section that will ask you about extrema, and it will be very specific. It will talk about absolute max and absolute min, and relative maxes and relative mins. So if we were going to talk about absolute minimums, this graph wouldn't have any because these two arrows are pointing down, right? This looks like it's the lowest point on the graph that we can see, but because these are pointing down, we know that there's going to be points that are lower. There is, however, a highest point on the graph. That would be the absolute maximum. That's right here. So the highest y value is the 3. For relative minimums, that's where we're looking for the bottom bumps, right? The bottoms here. So this point right here, even though it wasn't the lowest point of the whole graph, is where the slope went from negative to positive. That makes it a relative minimum. So we have one relative minimum. And then for relative maximum, we're looking for the tops of the bumps here. So we have two of those at -5 and at 4. And then lastly, we could do some end behavior as well. Since both of these arrows are both pointing down, we'd have two sentences talking about each of those arrows. That first one, this is talking about the left arrow. So as x is going to negative infinity, the left arrow is pointing down, f of x is going to negative infinity. And the second sentence is talking about that right arrow. As x approaches infinity, f of x is approaching negative infinity. Last, I just thought that this might be a good one to give you a little challenge. You could try finding domain, range, increasing, decreasing, extrema, and end behavior. Pause the video, see if you can find it. And then when you're ready to check out the answers, you can start the video again. All right, for domain, let me just get these up here. Domain, we had negative infinity to infinity. Range, the lowest was on the y was -9. So we have a bracket on that all the way up to positive infinity. Increasing, we actually had two intervals, here to here and here to here. If we wanted to make a slope number line for that, we could do that as well. All right, we can see those two positive intervals. So from -6 to 0 and from 5 to infinity, we only use the x values for increasing and decreasing. And decreasing, we're just going to write down those negative slope areas. For extrema, we had an absolute minimum. That's our lowest y value at -9. There was no highest. Whoops, I skipped over that. There's no highest, so no absolute maximum. We had a lot of bumps on this graph, so we have a relative minimum here and here. And right here is a relative maximum. And then both arrows were pointing up, so both of our end behaviors have f of x going to positive infinity.